The content in this video comes from pages 36 through 39 of your textbook, and it's meant to help you achieve learning objective number 8, which is to list and describe the 3 mechanisms of heat transfer. If you've not already done so, it's a good idea to skim pages 36 through 39 before you watch the rest of this video. Pay particular attention to bold words. And that should include the few words listed here. This is a very short video. And to the figures in the chapter and their captions. Plan to read the content more thoroughly before you attempt the vocabulary quizzes or concept quizzes. If you've ever attempted to pick up a metal spoon left in a boiling pot of soup, you realize that heat is transmitted along the entire length of the spoon. The transfer of heat in that manner is called conduction. You can see in your textbook, this is a person holding a nail in a flame over a candle. And what's being illustrated is that the heat is moving through the molecules inside the nail towards the person's hand. So high temperature molecules excite the molecules adjacent to them. So from this heat source, we move laterally towards the colder molecules and then eventually towards this person's hand. What's happening when you pick up a metal spoon in a hot pot of soup or hold a nail into a candle? The flame is causing the molecules at the candle end to vibrate more rapidly. Those molecules and free electrons collide more vigorously with their neighbors, and so on across the length of that nail. So conduction is the transfer of heat through electron and molecular collisions from one molecule directly to an adjacent molecule. So the ability of substances to do that, to conduct heat, varies considerably. Some substances like metals are very good conductors. Anyone who has reached for that silver ladle in the gravy bowl, for example, you realize hot gravy excites the metal in that spoon. Air, by contrast, is really a poor conductor of heat. Consequently, conduction is only important between the Earth's surface and the air that immediately touches that surface. So as a means of heat transfer for the atmosphere as a whole, conduction is the least important and can pretty much be disregarded when you're considering most meteorological phenomena. Objects that are poor conductors, such as air, are called insulators. Most objects that are good insulators, like cork, plastic foam, goose down, contain a lot of small air spaces. The poor conductivity of the trapped air gives those materials their insulating value. So snow is a really poor conductor. And like other good insulators, it contains numerous air spaces that impair the ability of the heat to flow through the system. So that's why wild animals tend to burrow into snowbanks to escape the cold in the snow. Just like a comforter, it doesn't supply heat. It just limits the loss of the animal's own body heat. Convection is a different thing, a different mechanism of heat transfer. Much of the heat transport in Earth's atmosphere and oceans occurs by convection. So convection is heat transfer that involves the actual movement or circulation of a substance, and it takes place in fluids, liquids like water and gases like air, where the material is able to flow. So if you imagine a pan of hot water being heated on a stove, that illustrates the concept of convection. The fire warms the bottom of the pan, which conducts the heat to the water inside. Because the water is a lousy conductor, only the water in close proximity to the bottom of the pan is heated by conduction. Heating causes that water to expand, become less dense, and buoyant. So the water near the bottom of the pan rises while the cooler and denser water sinks. As long as the water is heated from the bottom and cools near the top, it continues to turn over or produce a convective circulation. In a similar manner, some of the air in the lowest layer of the atmosphere that's heated by radiation and conduction is transported by convection to higher layers of the atmosphere. For example, on a hot, sunny day, the air above a plowed field will be heated more than the air above the surrounding croplands. As warm, less dense air above the plowed field rises upward, it's replaced by the cooler air above the croplands. In that way, a convective flow is established, just like the flow in a pot of boiling water. So the warm parcels of rising air are called thermals, and those are what hang glider pilots, for example, here on Cougar Mountain, use to keep their craft soaring. Convection of this type not only transfers heat, but also transports moisture, water vapor aloft. And the result is an increase in cloudiness that frequently can be observed on warm summer afternoons, even here in Washington State, as we look over the Cascades and can see cumulus clouds developing over eastern Washington. We can, by the time you're in Issaquah or I don't know, you pick a place in Snohomish County. You guys are more familiar with that. Get close to the mountains, Granite Falls. You can see big billowing clouds off to the east. Those are convective clouds forming. Atmospheric circulation consists of vertical as well as horizontal components. So both vertical and horizontal energy transfer occurs. Meteorologists use the term convection to describe the part of atmospheric circulation that involves upward and downward motion by air. By contrast, we use the term advection to denote the horizontal component of airflow. So the common term for advection is wind. So that's a perfectly fine answer. Advection. What is advection? Wind. A phenomenon that we examine closely in later chapters. So residents of the mid-latitudes often experience the effects of heat transfer by advection. For example, when frigid Canadian air invades the United States, we're feeling that now. It brings really bitterly cold winter weather. That's advection. Solar energy. The third mechanism of heat transfer is radiation. And unlike conduction and convection, radiation is the only mechanism that can transfer thermal energy through space, and thus is responsible for solar energy reaching the Earth. The important thing to note about radiation is that it travels like a wave. Everything is radiating some kind of energy. So the sun isn't the only thing that radiates, but it's the only thing that has wavelengths short enough, small enough, fast enough to go through space. So hot things, things with very high temperatures, emit very short wavelengths, while things that are lower in temperature but still above absolute zero emit longer wavelengths. So as the temperature of the object increases, so does the total amount of energy radiation emitted. And here you can see some different waves, types of radiation. So here's energy moving as a wave. And you'll notice X-rays. These are the very short wavelength. They carry a lot of energy per wave. Whereas the low end of the spectrum, here's microwaves, right? And we know to be cautious about microwaves and television and AM radio waves. We don't want to get too much radiation of any kind. But what we see as human beings, and we'll get into this a little bit next week, is the visible wavelength. Do whatever you need to do in terms of course content. Either watch this video again, reread the textbook, find this information online, but be able to answer these questions by the time we get to a midterm exam. Also, reviewing these questions, the concept check questions, will help you get ready for the concept of the reading quiz.